Let's talk about Fourier series and talk about why they're a very, very natural thing to think about. So as a warm-up, let's imagine we have this point here with coordinates 2, 4. Now, you probably know that this can be built by just looking at the two shadows on the x and y axis. And totally, like, we can just add them up. 2, 4 is just 2 times this thing plus 4 times this other thing. For instance, this point 4, 2, 5 in three-dimensional space, if we think about it just in terms of the x and y coordinates, we can see it's got 4 on the x-axis, 2 on the y-axis, and if we look in that third dimension, we can see that it's 5 on the z-axis. That's exactly why we can write this expression as a combination of 1, 0, 0, 0, 1, 0, and 0, 0, 1. If you've seen anything called linear algebra, this will start to look familiar. These are called linear combinations of vectors. But what if we have infinitely many dimensions? Now, I know what you're thinking. When would we ever have something like this? Well, let me show you a pretty convincing example. For instance, here's a pretty crazy graph. But when I show you the equation I typed in for this, you're going to see it's built from some very reasonable building blocks. There it is. It's built out of the simple functions 1, sine of 2x, and cosine of 4x. In fact, there was nothing special about those coefficients that we chose, and choosing any coefficients for, in this expression, a, b, and c would just give us a different combination of those waves to make something more complicated. And so now the big question is, what if you don't start with a particular decomposition? And so the big question is, what if you start with just some function? For instance, this is a function x cubed minus x. And you want to try and break it up in terms of those functions we just saw, the sines and those cosines. And the way we're going to split it up is by looking at this function as a combination of sine and cosine functions with varying frequencies, just like we did in the previous example. Now, the actual formulas for calculating these things is a little bit complicated, but it's not so bad. The basic idea is that we're measuring how our function interacts with the different sine and cosine functions of various frequencies. And when we put everything together, we get something extremely beautiful. Let's watch. And what we're doing is we're taking some point with 3 bits of information and we're slowly incorporating them. For instance, here is our point with only the information about the x coordinate. When we add information about the x and the y coordinate, we get a more detailed point. And finally, when we add in all 3 coordinates, we get our point that we actually wanted to study. And so if we look at what this does in the example of our function, well, if I only have one projection, I'm approximating it with this red curve here. And if I have 2 points of information, maybe it's a little bit better. But as you can see, as I add more and more detail, this graph is approximating my purple curve very, very well. In fact, if I go all the way up and look at the first 50 directions, I can get this wonderful approximation of my graph. This is a theory of something called Fourier series. If you want to know more about the details, let me know in the comments. I'm happy to follow up. And if this content is valuable to you, if you like it, please consider hitting the like button or subscribing. And in the comments, let me know what other types of videos you'd like to see. I appreciate your support. Thanks.